The English Channel is the busiest shipping lane on Earth. 22 miles of freezing, unforgiving water separate the United Kingdom from mainland Europe. For 2 centuries, engineers drafted plans to tunnel or bridge across this gap. The first serious proposal involved horse-drawn carriages and oil lamps back in 1802. In the 1880s, crews even managed to dig a test shaft, but every time, the ocean won out. That changed when the British and French governments agreed to a staggering $15 billion mega-project, more than double its initial budget. The goal was to permanently link 2 of the world's largest economies. To finish the link, engineers had to locate and follow a precise geological target buried 75 meters beneath the seabed. Look at this seafloor cross-section. 75 meters down is a narrow rock band known as chalk marl. It is hard enough to bore through, but crucially, watertight, and only 20 meters thick. If the tunnel boring machines drift too high, they punch into porous rock, cracking the ceiling and instantly flooding the tunnel. If they dip too low, the drill hits dense clay. That clay would instantly seize the cutting machines, cementing them in place. The entire 22-mile route had to stay perfectly within that 20-meter safe zone. Any deviation meant catastrophic failure. To carve through the chalk marl, they deployed 11 tunnel boring machines. These were 1,000-ton, self-contained subterranean factories, each equipped with a massive 600-ton cutter head to grind through solid rock. As the head cut forward, robotic hydraulic arms continuously lifted prefabricated concrete segments and placed them against the exposed rock. This simultaneous process created a watertight seal right behind the blade. The British and French teams faced entirely different hurdles. On the UK side, engineers detonated 250,000 cubic meters of rock to carve a flat launch pad into the vertical chalk cliffs of Dover. They excavated so much subterranean rock that they literally pushed the sea back. The debris was dumped into the water, forming a brand new 90-acre artificial landmass on the coast. The French coast featured looser, wetter rock. To launch their machines underground, the French crews had to sink massive 60-meter-deep circular pits near the shoreline. Because of the fractured rock, the French machines had to be completely sealed and pressurized. The workers inside these unventilated tunnels labored miles from the sun in a 122-degree Fahrenheit pressure cooker. 2 teams from 2 different nations fought entirely different environmental wars, digging blindly toward a common point under the ocean. To reduce the risk of a sudden flood, a smaller central service tunnel pushed ahead of the 2 main rail lines. It acted as a scout, checking for dangerous water seepage every single meter. Navigating those 1,000-ton machines perfectly inside that narrow 20-meter band required absolute precision. The operators steered the massive rigs, relying entirely on electronic gyroscopes and a single beam of laser light. After 39 kilometers of drilling, on December 1, 1990, the 2 sides broke through. The French and British crews met face-to-face deep beneath the seafloor. Despite starting from completely different countries and drilling blind for years, their final alignment error was less than half a meter off. But the enormous British boring machines were simply too massive to pull backward through the completed tunnels. To save valuable schedule time, operators steered the multi-million-dollar machines downward, burying them permanently beneath the ocean floor. The massive logistics hubs in Folkestone and Coquelles were finished, powering massive electric trains via precisely welded 25,000-volt overhead lines. The Channel Tunnel slashed travel times between London and Paris. Vehicles simply drove onto custom shuttles for a seamless 40-minute high-speed cruise underneath the sea. 2 years into operation, the ultimate nightmare scenario played out. A fire broke out on a heavy truck shuttle, fueled by tires and cargo, rapidly filling the confined space with intense heat and toxic smoke. This is where the strict 3-tunnel design proved its value. The central service tunnel, kept under positive air pressure, acted as a fully ventilated sanctuary and evacuation route. Every single person aboard that train survived. The project cost 11 lives and nearly double the initial budget. Despite those losses, the finished tunnels successfully turned a 200-year-old dream into a physical link that bypasses the sea entirely.